Hi, today we're going to try to show you what hashing is and an example on how it's being used. As an example, when you want to create a profile on Facebook, the first thing it asks you for is to create an account. So if we make an imaginary account here, saying like my name is Thomas, then it asks me for email. Let's say it would be my ITU mail. Wants me to repeat it, so I'm sure that I've given the right email. And then 1, 2, 3, 4, 5, 6, 7, 8, and my birthday, which could be whatever. There you go. When I then create my profile, it will send all the information encrypted to a database and decrypted. So now my information would be in a data set at Facebook server. From here on, hashing is going to be used, which is going to show, which is super smart. So if I had made this account, I would then be able just to write my mail to you, to BK, and my password up here, and then it would be able to find me in the dataset at their server and figure out exactly how my interface and all my information would look like. So now, after having creating our imaginary profile, Facebook would use an algorithm to make a hash value for each of our keys. So let's say the value of the mail, which would be the username, which would be equal to, it would spit out 3, and the other key would have a hash value of, let's say, generator 2. So what they use is a hash table, which pretty much here it says that under 3, this column, my data will be stored. But of course there can be conflicts, which would be if another user would have created an account with a hash value also becoming 3. So let's say Paul also has the value of 3 and Anthony has the value of 3. Then, because of chaining, my value would be under 2. The reason why it would be stored under 2 is because the other key, the password, was the value linked to the password was generated and became a 2. So by cross-referencing those two hash values, we could then figure out exactly where my data is. So every time now that I will be logging into Facebook, from the algorithm, the same hash values will be generated. They'll always be the same, and they are one directional. Which means that Facebook, instead of having to send my entire mail, my entire password, would only have to send the number 3 and the number 2. So there are 2 really important things to know about hashing. The first one is to know that the same input will always produce the same output, which means that in our case, the mail thkh at itu.dk would always produce the hash value 3 and not a 4, 6, or a billion. The second thing is that it's not possible to go from the output back to the input. There is no decryption key to hashing, it's one directional, which means it's only used to figure out where in our hash table we are located. So one of the abilities of hashing is actually encrypting your data. So as we showed before, the mail was generated into being the value of 3. So when we are sending our information for our login to Facebook here, if that's intercepted by a little hacker over here in the middle, then the hacker would only get the number 3, but would have no idea what that number would symbolize. So there is no mail to obtain for the hacker, there's no passwords, only the number 3, which is not usable for a hacker unless they would have the algorithm or the actual hash table. So to sum up the technology of hashing, hashing compresses your input data into a hashing value, which gives you the benefit of you can send less data, less bits and bytes, and that way you can actually save a lot of data consumption. The second ability of hashing is encrypting your data, so it's not your actual username or login information. In our example with Facebook, is not visible for anybody to intercept and store and use in between your computer and the server of Facebook.